So this is chapter 13, alkene, alkyne, and aromatic compound. This is the first part. We're going to look at here the differences between what we studied earlier, which were alkane. They are said to be saturated because they have as many hydrogen atoms as possible linked to the carbon atom. Carbon atoms are linked to each other with just one single covalent bond. Example on the far left is a propane, an alkane because it's saturated. Middle is a propene, 1, 2, 3 carbon atoms, so prop. I see a double bond between two carbon atoms, and you do observe that to keep that rule of having 4 possible covalent bonds, if you count the covalent bond, there are 2 already between two carbon atoms, so the one carbon atom on the far right has 2 hydrogens, and the one in the middle only has 1, so that's why it's said to be unsaturated. Even more unsaturated on the far right, you have 3 covalent bonds between the last 2 carbon atoms. So this is going to be, in that example, 3 carbon prop, 3 covalent bond, Y and E, propine. Also an unsaturated one. So how do we name them? Please pay attention, and again, do not burn any step. Follow the step 1, 2, 3, 4. Every single example where students make mistake is when they just go too fast. First step, name the parent compound. Find the longest chain that contain, in that case, the double or the triple bond. And then depending if it's a double bond, it's going to end with E and E. If it's a triple bond, it's going to be Y and E. This is your main chain. That's what you have to find the longest continuous carbon atom. Now, if you have more than one double bond or triple bond, well, you're going to look at the number of multiple bonds, and you will use those with the numerical prefix. Those are some examples. Here, I count how many carbon atoms I do have. 1, 2, 3, 4, 5. So it's pent. I notice a double bond on the last 2 carbon atoms, so it's a pentene. Second example, 1, 2, 3, 4, 5, 6 carbon atoms, so it's a X something. Triple bond, hexene. Now here, look at this one. This is going to be an hexene because you have to include the double bond. So I count 1, 2, 3 top, 4, 5, 6, not 1, 2, 3 top, 4 middle, 5, 6, 7 left, because I have to include the double or triple bond. This has the priority for naming your compound. Okay, so that's an hexene, not a heptene, because I need to include my double bond in the longest chain. Second step, need to number those carbon atoms. Well, this sounds a little bit tricky, but what you're going to try to do is to number those carbon atoms at the end that is nearer the multiple bond. So that's the example on the far left. I don't go 1, 2, 3, 4, 5, 6, left to right, but I go 1, right, 2, 3, 4, 5, 6, right to left, because my carbon number 2 is closer than if I were to count the other way around. That would be 1, 2, 3, 4, where I would see my double bond. Now, when you are at the same distance, well, you're going to look at the substituent. So this example in the middle, 1, 2, 3, 4, 5, 6 carbon atom, double bond, I know it's going to be an hexane. But look, if I number carbon 1 on the left side, 2, 3, carbon atom number 3 is the one that holds the double bond. If I were to look at the right side, start numbering the carbon that shows right here, number 6. If I put number 1, then number 2, number 3, carbon number 3 will also be the double bond. So when I have equal distance between the two, then I'm going to look at the substituent to decide which way I go, right to left or left to right. I see a methyl on carbon number 2, where if I were to label that compound with carbon number 1 on the right, 2, 3, 4, 5, then that methyl will be on carbon number 5. Still need to have the lowest number. And then if I look at here, well, I still have to have the priority for the double or triple bond. In that example, I have 8 carbon atoms, so it's a oct something, triple bond, octine with Y and E at the end. But here, if I number the carbon from left to right, the carbon number 2 is the one that holds the triple bond. If I were to number the carbon from right to left, that would be carbon number 1, 2, 3, 4, 5, 6 that will hold the triple bond. So I will go with the left side, not the right side, even if I have a substituent on carbon 2 if I were to label them on the right to left side. Okay? So first, the double bond or the triple bond has the priority, but if they happen to be on the same carbon number, so that would be equal distance, then I will number them so the substituent will be the second point I look at to number the carbon atom. Other thing, we're going to look at the one we call cycloalkene, where they're very common. And here the double bond carbon atoms are substituted cycloalkene, and they are assigned an index number 1 and 2 to make sure that the first substituent has the next lowest possible index number. So here, an example, I start where my substituent has the lowest number, that's the far right example. 1 includes my double bond, 2, 3, 4, but not 1 on the left side, 2, 3, 4, 5, because my methyl on the right side is on carbon number 4, my methyl on the left side is carbon number 5. And again, you need to start with number 1 is where you have your double bond that exists. And then the last step, you write the full name, assign the numbers to the branching substituent, list the substituent alphabetically, remember like we said, commas to separate the numbers, hyphens to separate the words from the numbers, show the position of the multiple bond in the chain by giving the number of the first multiple bond carbon. And if you have more than one, well, you need to identify the position of each of them and of course use the correct ending. So just here example, I look at how many carbon atoms I have, 1, 2, 3, 4, 5. So I know it's a pent something. A double bond, pentene, where is located my double bond? If I go from left to right, double bond will be on 1, 2, 3, 4. If I go right to left, double bond is on 1, so that's a 1-pentene. Second example, 1, 2, 3, 4, 5, 6. It's a X something, triple bond hexine, numbering the carbon atom from right to left, so the triple bond is on the lowest number of the carbon atom, so that's a 2-hexine. More tricky here. How many carbon atoms I have that include my double or triple bond? Well, 1, 2, 3, 4, 5, 6. So it's a X something, double bond hexene. How do I number those carbon atoms? Well, 1, 2 contains my double bond, so I go from right to left. Happens that the two up or lower are the same propyl, so there will be here a 3-propyl 2-hexene. Example on the bottom line, how many carbon atoms I have here? 8. A triple bond, octine. Triple bond has the priority over the substituent because it is not symmetrical. In other words, my triple bond is on carbon number 2 and my methyl on carbon number 7. So no question right here. I start from left to right. 7-methyl 2-octine. Now here is going to be 1, 2, 3, 4 but. I have 2 double bonds, so it's going to be di for 2, diene. Where are they located? 1 and 3. And where is my ethyl substituent on carbon number 2? If I were to number those carbons from right to left, there would be 1, 2, 3, 4. So that would be carbon 1, 2, 3, 1,3-butadiene. But then my substituent will be on carbon 4. I still want to have the lowest possible number, so 2 plus 1 plus 3 is lower than 3 plus 1 plus 4. Okay? And then the last example here, it's a cyclo because it makes a cycle. I have 1, 2, 3, 4, 5, 6 carbon atoms, so it's a cyclohexene because I see a double bond. Double bond starts number 1 carbon atom. Now I will turn 1, 2, 3, 4 clockwise, so my methyl is going to be on carbon number 4. If I were to count the other way around, that'd be 1, 2, 3, 4, 5. No, I prefer 4 over 5, lowest number.